Hi friends, welcome to my YouTube channel Mecons. In the last video I have given a brief intro about my YouTube channel and I have given basic idea about all the subjects. So here I am going to start with the engineering mechanics. Why I am starting with engineering mechanics? Because it's a basic thing for every mechanical engineer to understand the principles, to understand the terms and definitions. This engineering mechanics will deal with that. So I'm just want to start with engineering mechanics. So before going into the subject, we should know what is engineering mechanics, right? To understand this, we should divide this word to two: engineering and mechanics. So what is engineering? Generally, what engineers will do that we call as an engineering. So who is an engineer? The engineer who uses the already existing principle which is invented by the scientist. By using that principle, we are designing new products. That is what engineers will do. Not only designing, we also build things based on that design. So for an example, see that Newton. We all know he is a scientist. He invents many laws. One of the law is third law, the famous law. So by using this third law, many products are created. Even rocket is works based on that. Bike, gun, everything is works based on Newton's third law. So Newton is a scientist who invents principle and engineers who create products based on this principle. So basically, what is engineering means to convert um, paper work into practical work, paper to practical. So that is engineering. This is a question I asked in the last video. What is engineering? So here is the answer: the paper into practical applications. So then mechanics. Mechanics means, see, if we design one product like a bearing for an example, I hope it's look like a bearing. So we are applying force on this, force or torque apply on the bearing. Due to that force, some effect will happen. Either it will rotate or it will deform, it will fracture, right? So to study about these effects on this product is called as mechanics. So to study of effects of the body when it is in uh, force, when it's applicable to force. So while we integrating this towards, we can find what is engineering mechanics. So what is engineering mechanics? While creating a new product, we assume that that object is applied. Sorry, that object is subjected into some force. So due to that force, there might be some effect, right? To study about that effect is called as engineering mechanics. We are creating a new product, the force applied to that product, and due to that force, there might be some effect on the body. To study about that effects is called as engineering mechanics. Simply is analyze the force. We call it as engineering mechanics. So this engineering mechanics is divided into mainly two categories. One is solids and another one is fluids. Solid is generally it's to retain its shape and size during the application of the force. When its size or shape is changed, means it's we consider as a failure in the solids. But in fluids, it won't have a proper shape. It will retain its uh, shape according to the container. See, if it's stored in a tank, means it would has the shape of this container. When it's flow into the circular ducts, means it would has the shape of the ducts. So this is the difference between the solids and fluids. To study about this, Solid objects or fluid object is we call it as mechanics of solids and mechanics of fluids respectively. And mechanics of fluids is nothing but the thermodynamics and fluid mechanics. Heat and mass transfer is comes under this mechanics of fluid. Mechanics of solids mean the remaining subject like theory of machine, strength of materials, design of machine elements is comes under mechanics of solids. So for the mechanics of solids, we have two categories: mechanics of rigid bodies, mechanics of deformable bodies. Mechanics of rigid bodies means, see, I should explain what is a rigid body first. See, we consider this is an object. We place 2 points. The distance between the 2 points is considered as a d. So while application time of this product, the distance between two particles, which is d, it won't change during its entire lifetime. If it's changed means even it's a negligible means it won't. It's okay. It changed more than that means we'll call it as a failure. So that body is called as rigid bodies. But what is deformable body? Deformable bodies means the distance between that 2 points will change. Example, if you consider belt, it used in mainly in the pulleys or conveyors. So distance between the two points would be d here before this pulley. So in the pulley, the distance between that 2 points would be d plus x. The distance may get increased or decreased. Here it would get decreased because it's a slack side, it's a tight side. Here it would be increased, here it would be reduced, d minus x. So the distance between the 2 points would change here. That's why we call it as a deformable bodies. But in a rigid bodies means the distance between that 2 points would remain the same. And to study about that rigid bodies, we call it as a mechanics of rigid bodies. We further classify this rigid bodies into two categories. One is statics, another one is as dynamics. Statics means a study of object when it is in rest, and dynamics means study of object when it is in motion, when it's moving. So this dynamics is further divided into two: kinematics and kinetics. What is the difference between kinematics and kinetics means? Kinematics is it won't directly involve with force. During the calculation, we don't consider force. Instead of force, we consider acceleration, velocity, displacement, those things in this kinematics. In kinetics, we directly consider force. Okay, that I just want to ask one question, that how we can indirectly consider force here in a kinematics, because in kinematics we don't consider force directly, which means we are doing it indirectly, right? So how force can be indirectly calculated? Yeah, I have the answer for that. See, Newton's second law is the answer for that. What Newton's second law states that force is equal to mass into acceleration. When mass is constant, force is directly proportional to acceleration. So instead of considering this force, we are considering the acceleration in this kinematics. So in the kinetics, we directly consider the force. Okay, so I think I have explained all the types and subtypes of engineering mechanics. So this is a syllabus we are going to study in the further videos. In the first four topics comes under the category of statics. These three comes under the category of dynamics. It is very interesting. This both statics and dynamics. We see it in the further classes. And thank you. That's all. This video is we have explained what is engineering mechanics. and types of engineering mechanics, and also the syllabus which we are going to study in further videos. Yeah, thank you, and I expect your feedback in comment box. Thank you.